All right, so now we can let's continue with this part of the first tutorial. So now the next thing we now we can uncheck all this, check, uncheck, and then what we need to remain with is the stream laying and stream definition. Was stream recommendation and stream definition. So as you can see, this could be River Nyamwamba. This, so I can zoom. So which means that the river flows from this is the upstream and this is the downstream. So we can zoom and so this is River Nyamwamba. So I may be interested in a point somewhere here, maybe at some point here. Maybe some point here. So the next thing here, you go to project setup. So you can go to start new project. So you can click new, then you say okay. Okay, so project name, maybe I can call it Nyamwamba HMS. Then description, you can put anything. Maybe you are doing flood modeling or you are studying the hydrology of an area. So any description. So metadata here you can put the date today. So I can put 5/02/2021. Then I'll say okay. Okay, that's good. It gives us two steps. First of all, run, add project points, and then two, you generate the project. So I can say okay. So add the project, add project points. This is the icon, this is the two. So you click on it. I'm going to put my outlet at this point. But of course, depending on the interest of the study, it may be the point source, it may be the outlet can be chosen as any point of interest. But normally in the field, you can go and look for a coordinate or the GPS coordinate, and then you locate exactly that point of your interest. But in this tutorial, I will just put a point there to be as my outlet. So from here, I say okay. So that will be my outlet point. So from there, they say the next thing or step is to generate the project. So you can see this are all fine, but only here row them, you choose them Kasesa, and then you say okay. Okay, that's our catchment area. So and then you say okay, so that it can generate for the highlighted area. Okay, good. You click OK. Well, that's good. So this is done. So now the next step, so we are done with project setup. So you can go to basin processing. If you wish to match the basins, as you see, the sub basins are many. So you may need to reduce them to a given number of basins that you wish to have. You can say, let me have 5, 6, 7, or even 3, or even 2, or even 1. But in this study, uh, I will show you, I will only reduce to some of them, then we continue. So in this case, to show you for the purpose of this story, you need to click select, then you can select and give a number of persons and then you person merge. So you see they are selected, so you can merge that into one. So I can also come here to this, then we also merge them. So those are already two. So you may wish to continue. So it's a problem. So let's see. Let's try another. Okay, you can have some something like that reduced, and then from that you can go to characteristics. Click river. Okay, that's good. River length is that. So you can go to river slope. So in this section, we now attach the watershed characteristics of an area. So whereby we shall need to know the slope of the river, the length of the river. However, in this In this step here, in the lesson characteristics, you find that the processes keep disturbing and failing. But if it shows you an error of background through an exception, it means just the system itself or the software. That's not an error. So you have to repeat severally so that you come up with what? With the results. So when it gives you this is not an error, it has failed, but it's just a warning. It tells us that the spatial reference does not have Z unit, having Z assumed as one linear unit. So that one is not an error. So that means that with that, it has executed. So we go to Bayesian slope. Yeah, Bayesian slope. So here it asks for the Bayesian. So normally to avoid that, you have to come here. Our slope is here. So you can bring it down here. Okay. So can now again go back to Bayesian slope. So you can select it here. So this is good. So you say, okay. So it has again failed. So you click that Bayesian slope. Then you say, okay. So you have to be patient with this when you reach that point. Okay, good. So Bayesian slope. So we can go to lowest flow paths. So this we say, okay. Okay, still this is okay. So after that we go to Bayesian centroid. This is okay. That's good. So shall go to centroid elevation. So I can browse for my yes, okay. Okay, good. So I'll move this. So I can come again finally to centroid lowest flow path. So then here they need the centroid. So you can go to centroid. Then you can also here it needs the longest flow path. Uh-huh. Okay. So the centroid, the basic centroid is, we can say, it's actually that center points in a catchment. For example, you find that there are those lowest points in a catchment, like where water can collect. So that's why we do the basin what? The basin centroid. Then at that point, and also see the distance, the longest flow path for the centroid. So how much from the upstream to the downstream in that specific particular basin. Okay, this one centralized profile is okay, good, done. So which means we are done with this section. So we can go to parameters. So here in this case here we need the parameters that we are going to use, or we are going to import them, and we take them to HMS, the software itself. So what we are using here is Geohms, which which is just, it helps us to generate that file, the maps, the basins, and all that to HMS, so that we can do the modeling from there. So here we shall say select, and then sub-basin loss method. Of course, now this brings us, we are doing hydrological modeling or hydrology. So we know very well hydrology or water cycle or hydrological cycles, just the movement of water, let's say from the atmosphere, then you come on the surface, then you go to the ground and groundwater movement. So you find that when when it rains or when it precipitates, there are those losses. Some water is lost, maybe through interception, maybe through evaporation, so or transpiration. So that is water that is lost. So if an area receives a certain amount of rainfall, then how much is lost? So here we now select the, the method that we shall use. And here we'll select SS curve number. We are going to use curve numbers to generate our water loss in this case, but that tutorial will come maybe after we finish this, but it will also come. So then there is transform method. That transform method is actually, HMS is just a, okay. I was saying, uh, HHMS is just a rainfall runoff model. So it actually converts rainfall into runoff. So that method that converts rainfall whenever it precipitates to that runoff, whether surface runoff or subsurface runoff, what could that be? Or which method do we use? So there are very many of them here. So you select. So in this case, I shall select SS Kavanaugh transform method, unity transform method. So then the base flow method here, in this case here, in a catchment area, I expect, or we always have that base flow. And this is basically in a river, or what we call hydrological routing. But base flow is that part of water in a river that remains flowing even during dry season. It's always there. It's always constant. So you may choose to select a formula there, whether monthly constant, where you know that it's always that value according to the gauging station, how much it measures monthly constant. Maybe if you wish to use bounded recession, or you wish to use a linear method, I mean a linear research, so you select. But in this case, I'm going to select none. Then none, sometimes depending on the area. For example, in northern Uganda or dry areas, you can select what? None, because you may find the rivers or the streams which are there during dry season, they dry up. So you find there is nothing in there. You don't have any kind of flow. So hydrological river routing, this one here, we talk of where as it precipitates, we have that runoff, that surface runoff. So water can move, maybe it can infiltrate, but there is that runoff that goes directly to the what? To the river. In other words, it contributes to the what? To the river. So here we select the what? The method. In this case, I'll select lag method or masking gum, lag method to help me as river routing method. So from here, I've already selected the processes. So I say, okay. It also throws an error. So I can select. So say, okay. Okay, good. So parameters. So we go and we automate the river auto name. Okay, this is good. So we continue still, but let me first save. Okay, good. So we go to basin auto name. Okay, good. So the next thing, so we finished auto grid cell processes. This is if you are using fluid rainfall. Then sub-basin parameters from raster. So this one, we normally use it like the methods we've chosen. We would wish to select the curve number grid, but in this case it has not been given, or we've not yet worked on. So, but we are going to have that tutorial also for curve numbers. Okay, good. So we we can have these segments. So all this is done. So we can visualize something here. So can we go to this? Okay, so now if if we had curve number lag method, if we had the CN, we would put it there, or the curve number grid, but we shall generate it there. We shall generate it. Normally, you first generate it, you store it, then when you reach this point, you only put it and all will work out. So with this one, we would have done it, but it says none step or feature has been skipped. So we shall not do that. Let's continue now to HMS. So, but before that, I would wish to add some data sets here, some things that we've done but are not being displayed. So we can have the centroid longest flow path, and then centroid longest flow path. I need to have these ones to appear here. Yes, good. So you can see. So from here we go to HMS processes. So you can map this to HMS, because actually HMS is where we shall work from. But here we are just collecting kind of data and we take them that side. So we shall put longest flow path, then and then centroid here. So this one also will become longest flow path. So I can say okay. Good. Then we shall go to check data. Data is complete, has no error. So you can go to schematic view. And also say okay. Okay, good. So you can go to toggle legend. So this is so beautiful. You can add the coordinates. Coordinates added. So you can go to prepare for, and okay, so we go to background. background shape file. So we need now the sub basin. We want to take this one into HMS. Then select, then I'm here, I'm here. So background shape file is done. We go to basin model. Okay, that's good. So we go to grid cell, we go to metallurgical, you can use this. Okay, then we can create HMS what project. So we create it so that when you reach there, you just open it for further modeling. So where my project location is, I need it here. It is in tutorial. It's actually here. So then you select the basin file. It is there, Nyamamba. Then also select it. It's also there. Gauge. It's also there. Then run. Maybe I can say sim version 1. Then time interval. Maybe we are going to use minutes. But this one can be changed. 144.0, that's a day. So I can say okay. So it has been copied or created. So then I come to import. I now import this HMS file. I can say import. I can select the person to import. I say okay. So HMS file is successfully imported. Good. So from this now we are now done with the HMS. So the next thing is to go to HMS. So the HMS let me say, let me use 4.3 version. Okay. So HMS. So now this is the HMS. Now that we are now from that side, so we are here. We are now from this side, but of course, what we need to do is to select this file. I mean, what we've already gotten. So I will go new. This is a HMS interface, but of course this one is black. I mean, it's a blank space. But when you are starting a project new, that's when you are creating a new one from there. But open, that means you are opening an existing one. But when you come here, it's not there. So I will browse for it. So I will browse for it. It is in here. Then tutorial 2. So it is here. So I select it and I convert. Okay, so this is good. So it has 4 parts: basin model, meteorological, control survey, and time series. So you can see that is the now. It was blank before, but now it has some features or the map, the basin model. So from here We can add map layouts. So go to tutorial. So I need this. So the map layer I take, so then I can add again for the river. Good, so that's fine. So that's okay. So this is our basin model. So from here we shall continue in the next tutorial how we can model this one in for further analysis, and then we see the results and how we can what analyze it. Otherwise, this is the end of the second part of the tutorial.